Deepraj, Dhanlakshmi, Anup, Balamurgan, Gokul, Kameswar,
Yes,
Silva.
sir.
Good morning, everyone. Here,
Good morning.
agenda for today's session is we are going to start a discussion on Apache Hive. Okay. So here, so far in our previous sessions, we have discussed about the following thing: how to go for installation of Hadoop, both single node as well as multi-node clusters. Okay. So here, single node cluster as well as multi-node cluster. And we have discussed about some basic HDFS commands, Hadoop distributed file system commands. Here, are you aware of the differences between this local file system and Hadoop file system in this perspective? How Hadoop file system differs from local file system, and what are all the commands that we can make use of to do activity on Hadoop file system as well as local file system. Here, the file system that we are referring local file system is Linux file system. Okay. So here we are in today's agenda. We are going to start our discussion on introduction about Hive. Then we are going to discuss about its architectural perspective. We have already started the discussion of introduction in our previous class itself. Being here in today's class, we have 3-4 newcomers. Let me devote 10-15 minutes to start with the introduction, followed with the architectural perspective of Hive, and then we go for the installation of Hive, how to install and configure Hive. We are going to deal with these data types and various operators that we can use with Hive. And we are going to deal with the Hive tables. Under the tables, we have a lot of tables. We have Hive managed tables, and we have external tables. Then we are going to, if time permits, we are going to discuss about the concept of partitioning. One of the most important concepts, partitioning and bucketing. So this is the agenda for today's session. Okay. So let me first start with introduction. Even though for certain people we have discussed this introduction, let me start with new. Okay. So we have already discussed that. So in terms of this Hadoop has been concerned, there are two major classification. One is HDFS and another one is MapReduce in terms of Hadoop architecture has been concerned. HDFS is nothing but used for data storage, and MapReduce is nothing but the programming model used in Hadoop. Okay, a programming model, basic programming model using which we do data processing. Where you have your data stored. Here you have data stored in your data nodes, a cluster of machines called as data nodes. We may have multiple data nodes according to the clusters. Okay, you may have data node 1, data node 2, up to you may have n data nodes. So you have data stored in these data nodes. You have data stored in these data nodes. If you want to do some process on top of it, the only model that is allowed is MapReduce programming model. Okay, here it is respected to with 1.x. In 2.x we have multiple models. Apart from MapReduce, we can go for a graphical processing, real-time processing, transaction processing. The thing that we are discussing is Hadoop 1.x. In 2.x it support, as already told, apart from MapReduce, it also supports some other programming also. That feature is called as multi-tenancy. 2.x support multi-tenancy means. So here you use MapReduce into, if the same case, if it is MapReduce, you have a framework called as Yarn, a new framework on top of your HDFS. You have a framework called as Yarn, yet another resource navigation. Here it support MapReduce. It support online transaction. It supports some graphical processing. Like you can able to run multiple applications and different types of applications. The key term is you can run multiple heterogeneous applications concurrently. This feature concurrently means at the same time. This feature is called as multi-tenancy. 2.x support multi-tenancy. How? By the use of a new framework called as Yarn, yet another resource navigation. Here the MapReduce here called as V2. Here the MapReduce here called as V1. MapReduce version 1. In 1.x, the drawback is it doesn't provide a multi-tenancy. That is, it support only MapReduce. How you can write a MapReduce program? You can make use of the above said languages like Java, Python, Perl, sorry, any language, Ruby, okay, to write a MapReduce program. So writing a MapReduce program involve the following things. You want to write a map function, and you want to write a reduce function. Intermediately, the input will be given to the map function. A map function need to be inherited from a mapper class. Those who are aware on Java may have understanding. You will be having a class by name mapper class. From the mapper class, you want to create your own mapper class, and in that mapper class, you want to make use of a map function. Okay, this map function is a inherited functions from the base mapper class. Similarly, there exists a reducer class. From the reducer class, you want to create your own reducer class. In your own reducer class, you want to inherit this reduce function. Here, the concept of inheritance and overloading will be takes place here. Okay, here we have a original mapper class, a built-in mapper class, and a built-in map function, and you want to create a new mapper class which inherits the built-in mapper class, and in that new mapper class you want to override a map method, okay, which is already present in the mapper class. So we will have these sort of discussions in a more in-depth manner while we go for discussion on MapReduce. So it is to make you how complex it is, I am letting you know these things. Okay, so if you want to write a MapReduce, you want to write this sort of complex activity, mapper, reducer. So intermediately shuffling and sorting, combining and partitioning. These are all some additional phases that happens. So writing a MapReduce program in Java or Python or Perl are a little bit more complicated. So for example, for your business logic, if a program runs into 100 or 150 lines of code, if it is in Java, the same thing if you go up with Python, you can able to complete within 75 to 100 lines of code. A language like Python will have more built-in functions. So even though if it is very simple, it will be difficult for the programmer to write the business logic if that's the case. So to make it simplified, Apache Corporation itself is having two tools. One is Hive and another one is Pig. We call these two tools as a Hadoop ecosystem tools. Using these tools, you can easily write a MapReduce program. So why so? Because Hive and Pig are almost similar to SQL, normal structured query language. Okay, user will write a coding in Hive, and Hive intermediately will transform the coding into MapReduce, and you can able to do that process on top of the data stored in the data nodes. The advantage here is, if a Java program needs around 150 lines of coding, if a Python program needs around 100 lines of coding for a particular business logic, the same thing if you have incorporated using Hive and Pig, at the maximum you can able to complete within 10 to 15 lines of coding. Such a powerful tool, Hive and Pig. So in terms of a programmer perspective, there are two advantages. One is a number of lines of coding is very less in number. So the storage space, the time taken for execution will also be very less. The second advantage is it is very simple. Also because writing a program using a language like structured query language compared to that of writing a program using Java or Python like languages is very simple. Okay, this is the advantage of going for Hive and Pig. So it was Hive and Pig was not initially developed by the open source corporation. Here Hive was developed by Facebook, and laterly Facebook given Hive to this Apache Open Source Foundation. Apache Open Source Foundation, they had some new features on top of it, until now it is an open source called Apache Hive. So here Hive uses a language similar to SQL. Hive uses a language called as Hive query language, HiveQL. Okay, very simple. Almost 95% is similar to SQL. Even though it is similar to SQL, it is not a structured query language. It differs by SQL in several perspectives. It is not a structured query language. You want to be very careful in this perspective. Okay. Similarly, this also Pig uses a language called as Pig Latin. Hive query language, which is almost similar to SQL, and Simpig was initially developed by Yahoo. Pig uses a language called as Pig Latin. The major differences between Hive and Pig is that Hive support only for structured data. Pig support structured data, semi-structured data, and unstructured data. Okay, so usually Hive stores data in forms of tables, Hive tables. Pig stores data again in forms of tables. The table here called as a bag. Let me discuss those concepts later. Okay, the storage component of Pig is bag. Here it stores as of your RDBMS, Oracle, and MySQL. It will store data in a table. Okay, so these are all some of the basic things associated with Hive and Pig. And more importantly, we call Hive as a data warehouse tool of Hadoop. Data warehouse tool of Hadoop. Whereas Pig we call it as a data flow language, DFL. Please make a note. Both Hive and Pig, even though it is similar to SQL, it is not a relational database. You can't make use of Hive or Pig to do online transaction processing like you are using Oracle, MySQL, SQL Server like thing. Okay. So it works on top of the data, and that is the data that you have stored in HDFS. It won't work on real-time queries. It won't support updates, low-level updates like this. So there are a lot of differences compared to that of a normal SQL. Okay. The advantage is very simple in terms of programming, less number of codes. In terms of number of lines of code is very less in number compared to that of the writing a program with a normal programming language. Okay, so and most important difference with respect to this Hive and RDBMS is RDBMS is a structured query language. It is not a structured query language. It supports, even though it is similar to structured query language, it doesn't support the features of a structured query language. Okay, so here you can't make use of a Hive for OLTP, no OLTP. Here RDBMS is meant for online transaction processing. Hive is especially meant for OLAP, online analytical processing, to do analytics on top of data. RDBMS is meant for online transaction processing, which is subjected to frequent updates. It won't support a low-level update. Once you go through, you will have a meaning for each and everything. It won't support a low-level update. Please make a note of all those things, and I will let you know one by one. So these are all some of the key features associated with Hive. Okay, so if we go into this architecture, so you have data. Let me take, you have your a database server. This is your data source. Let me imagine you have a table by name employee, which contains employee number, employee name, and then salary. Okay, on Ram some 9,000 to Arun 9,500, 3 Raj 10,000. Okay, this is your structured data. So here you have your HDFS, you have your Hadoop cluster, under which you have multiple data nodes in your cluster. Here your data need to be stored for analytics purpose. Okay, data node 1 up to data node n. So this corresponds to your HDFS. Here, who is responsible in bringing the data? Here you have a tool by name Scoop. We will going to discuss this tool, which is responsible for fetching data from these data sources. Here the data sources is the RDBMS source in this example. It is RDBMS source. It fetches the data and places the data in this data nodes. Okay, across these data nodes, it places the data. So here we use this Hive for doing process. Okay, So here, how the data will be stored here? This data will be stored in form of a text file. Let me make it as a employee.text. How it will be stored? It will be stored in the following manner. One, RAM 9000, a tab separated format or a comma separated format. Two, Arun 9500. 3, Raj 10,000. This is the way by which in a text format only the data will be stored in your HDFS. Please make a note. If it is a text format, the user can't able to query anything. As of here, he can't able to query anything. In this case, if a user want to view those people with the salary greater than 9,000 means he can simply issue a query. Select start from employee where salary greater than 9,000. Okay, that is possible here. Why so? Because being it is a structured data, that is possible. The same sort of query is not applicable here once the data is brought into the HDFS. Why so? Because the data here will be stored in forms of a text file. Okay, so it doesn't know it now the data which is in a unstructured, or we may call it as a semi-structured format, or it is a unstructured format. Okay, now how you can able to query the data? You want to add a structure to the data. How you add a structured data? You can make use of these tools, either Hive or Pig, or you can write your own coding in the programming languages that we have listed for adding a structure to the data which is stored in your Hadoop cluster. So here, how Hive had a structure. For that purpose, Hive uses another component called as Hive Metastore. Hive uses a component called as Hive Metastore. The Hive Metastore will store all the metadata informations that is needed to make Hive to understand what it is in the underlying HDFS. The Hive Metastore is a database. So the default database here comes with the Hive is Derby database. These are all interview questions. You can also, if you want this Hive Metastore to be configured with MySQL or Oracle, that is also possible, but that is enough. Derby database, Hive comes integrated with Derby database. Okay, so here this Hive Metastore will manage all the metadata information. For example, for this particular employee.txt file, how Hive manages here is, it will manage in the following format. There is a text file by name employee.txt. The file containing 3 fields. Okay, you consider the first field as employee number. Consider the second field as employee name. Consider the third field as salary. So the employee number need to be given a data type integer. The employee name, it should be a varchar. The salary should be a float. Like this Hive Metastore will add this sort of metadata information. Whenever a user issue a query, select stock from, for example, Hive. That you here, what happened is this query, the Hive will make a check with this metadata. So for this particular query, which data that need to be referred in this HDFS, like all the information here, the employee text here is mapped to employee Hive, like all the metadata information will be stored in Hive Metastore. Then once a user issue a query, Hive what it will do, it will refer to the Hive Metastore and it will came to know, Hive will came to know, okay, the employee Hive table means that you want to map data from this employee.text. So under employee.text, we have 3 fields. The first field need to be taken as number, like all the informations Hive will came to know, and the Hive what happened, it will internally transforms the query, Hive internally transforms the query into corresponding map and reduce function, and it will operate on top of it and it will fetch the result and give to the user. So this is the way by which Hive can able to add structured information to unstructured or semi-structured text file that it is stored in your HDFS. Okay. So for that, what you need to do, first thing, you want to create a Hive table. For mapping this content, you want to create a Hive table. Then second thing, what you need to do, you want to create a, once you create a Hive table, metadata information for that table to which the data set the table is going to associate, everything will be created. Create metadata information in the Hive Metastore. And after that, you want to load the data from this HDFS into Hive table. So after that, the user can query step 4. The user can query the Hive table as if the user can query normal RDBMS. Okay, so these are all the ways by which you can get the data from the RDBMS sources. Here, if you are using Hive, the data need to be either in RDBMS sources or it can be a data warehouse. Both thing is supported. That's why you can crawl data from data warehouse. You can crawl data from RDBMS sources, and you can add the data here on top of it. If you are going to work with some real-time sentiment analytics by crawling data from social networking sites like Facebook, Twitter, etc., if you are going to work with some sensor-related data that you have crawled from IoT devices, under that circumstances, what you can do, it is recommended to go for big. If the data that you are going to make use of with the machine-made data, such as unstructured, semi-structured data, if you are going to work with some real-time audios and videos, so it is recommended to go for big. Else, if you are going to do some analytics on top of your RDBMS data, structured data, it is recommended to go for Hive. Once our discussion on Hive and Pig has been over, we will have around 6 to 7 use cases. Minimum 6 to 7 use cases. I will let you know where to use Hive and where to use Pig with some real data sets and how to do process on top of it. You will have a clear understanding. Our curriculum is giving almost 25% of attention towards learning Hive and Pig. Why so? Because it is more important for both developer, Hadoop developer. Also, if you are looking for a job as a Hadoop analyst, this Hive and Pig plays a key role. So that's the reason why we give more focus. So a developer perspective, we will be making use of Hive and Pig in an effective manner. Okay. So if you go for any Hadoop developer opening, almost 95% of the business logic will be written in Hive or Pig only. Only around 5% alone you need to go for writing code in terms of language like Java or Python. And for that 5% of requirement only you need to go for. Even if it is Java, core Java is enough. Python is very simple. Compared to that of Java, it is very simple. Even a child can able to learn Python. Okay. Our curriculum also deals with this Java. Or we can go directly with Python. It is your choice to decide which one that we need to go for. Okay. So these are all the various ways by which you can bring the data from data source. It is in this example I have listed you a single data source. It may be multiple data source. You may have a data crawled across multiple data source. I will let a scenario we have already discussed. Let me take a scenario of Megamart, a departmental store famous in Tamil Nadu, selling apparels, men's and women's apparels. Okay, dress materials. They are doing dress materials. So the Megamart. So let me take this small use case. Megamart is having around 100 branches throughout Tamil Nadu. You can map it to anyone. If it is Megamart, you can make it as a Reliance or you can make it as a Walmart for US people. Okay, 100 branches. Okay, Megamart has announced a sale. Yeah, reduction sale. A reduction counting up to 70% of reduction. Okay, in all those branches. We have branches at Chennai. We have branches at Madurai. Similarly, we have branches across all. We have branches at Trichy. Like we have 100 such branches. Branch 1, branch 2. We have, assume that we have 100 such branches. Okay, each and every branch. These are all data sources. These are all data sources. Each and every branch is having a RDBMS. Also because you need to do frequent insertion, frequent deletion and observations. All the transactions are recorded here. Each and every day transactions that is taking place on the particular branch is recorded here. So this is corresponds to OLTP. If a customer can buy certain items, then items need to be updated. If you want to exchange those items, it need to be removed and it need to be re-updated like this. So you have each and every the server equipped with the RDBMS. So it may be a Oracle. Let me make it is a Oracle. Okay. So similarly, you have this Madurai up to 100 branches equipped with this OLTP servers. Okay. Here, what the Megamart CEO is interested. Okay, he is interested in identifying. Okay, the sale is for 2 months period. Then that is the sale is for 2 months, 60 days of sales. Okay, what he is interested? He is interested in two perspectives. He is interested in finding out the sale of Louis Philippe, Van Heusen and Peter England. So how much of total sale accords to this Louis Philippe brand, Van Heusen and Peter England. Okay, then he is interested in finding out the sales associated with these branches, not only the associated with these items. He is also interested in the second perspective, which branch produces minimum sale of opposite items and maximum sale of opposite items. These are all his requirement. For this requirement, you want to, this is your business logic. You want to write a code. Okay. So here for doing analytics, you can't, it's a day-to-day transaction. Let me imagine each day at the average there are 5,000 transactions each day. At the average, the Chennai branch may have 10,000, Madurai branch may have 7,000, Trichy branch may have 4,000. Let me make it at the average 5,000 transactions per day. Let me assume. So for a single branch. So how many days? 60 days of transaction. 60 into 5,000, therefore 3 lakhs at the average 3 lakhs of transaction per branch. How many branches are there? Totally there are 100 branches into 100, 3 crores. Total transaction is 3 crores. Out of these 3 crores, these 3 crores of transaction has been spread across the servers of these 100 data sources. Okay. So here what you need to do? First, the data need to be bring into the Hadoop cluster. You have data nodes. In the data nodes, you will be storing this data. Okay. You have, let me imagine you have 10 data nodes in your cluster. The 3 crores of transaction need to bring here into the data nodes, into your HDFS for analytics purpose. Okay, so for that what you do, you will configure Scoop, a tool called as Scoop, as I already told. So once the activity on every day has been over, if we configure Scoop in such a manner that to fetch the data from these data sources and to place the data into the HDFS, so Scoop will do the thing. Here the data, when it is placed in HDFS, it won't be a structured data. Here the data will be stored in forms of a text. Here for that you want to write the MapReduce. What is the logic that you need? You want to write the logic to identify the items Louis Philippe, Van Heusen and Peter England, and to find out the total sales of those items. Okay. So this is corresponding to the MapReduce logic that you want to write. This logic can be written using Hive in a very simple manner. You can also make use of it for doing the same activity. Okay, so we have already discussed. Why I had recalled this discussion is to know what are all those data sources and what is the scenario under which you want to do a particular analytics. The analytics that you want to find out here is to finding out the sale of the items, and in finding out the branch, which branch resulted in a minimum and maximum. Since the data is distributed across these 100 different servers, so first thing you want to integrate all the data that is crawled from these servers for analytics. So this will be taken care by the Scoop. It will fetch the data and will place the data in a common storage, and you want to write a MapReduce to do that activity on top of it. So what happened here in this case, all the data when it is stored here, it's in a text format. So Hive will create a table called Hive table. You create a table, Hive table, and the Hive table will have the metadata information stored in a Hive meta store. From this, Hive can able to query the data here. Okay. So our use cases also deals with fetching the crawling the data from data sources and how to do business logic on top of it. Okay. For that we have 2 to 3 live use cases like airlines data set, predicting a share prices like thing and so on. Okay. So this is the way by which you can make use of your Hive for data analytics that is fetched from the different data sources. Okay, you want to be very careful in this discussion. Data sources are RDBMS sources. Data sources are RDBMS sources. Okay, so now we are going to discuss about this architecture of Hive. So in terms of this Hive architecture has been concerned, you have three major things. One is Hive user interface. and Hive internals and Hive database engine. You have the following three things. Okay, so user interface has been concerned. You can make use of the following. You have a CLI interface, Hive command line interface. We call this as a Hive shell. Now you can interact Hive with a web user interface, or you can go up with third-party tools. Okay, if you are going to make use of some distributions, we may already aware of what is distributions. We have a Cloudera distribution of Hadoop. We have a Hortonworks distribution of Hadoop. We have a MapR distribution, IBM distribution. There are lot of distributions, etc., etc. Those distributions will have a specific interface, such as you have a Hue followed by Cloudera and Hortonworks. You have an interface called as a HD Insight, which is followed by IBM. Okay, so similarly you have a interface Ambari, a open source interface which support all those things. Okay, you can make use of the opposite interface to interact with Hive. In our curriculum, we are going in several use cases, around 3-4 use cases. We are going to work with the use cases using the Hortonworks distribution, under which we will be using the interface Hue interface. Okay, so at that time you will know how easy it will be if you go up with these interfaces. So these are all the various interfaces using which the user can have an interaction. Okay, he can make use of any one interface. At the backend, where Hive's data will be. Hive will store the data not in its separate entity. The data may be in your HDFS, or the data may be in a database like HBase, or it may be in a database like MongoDB, Cassandra, etc. in any NoSQL database. Okay, so you can have your Hive data stored directly in your Hadoop distributed file system, or in a database, NoSQL database like HBase, MongoDB, etc., etc. Okay, this is the backend layer. The Hive internals, okay, the Hive core layer. This is the Hive core layer. This is Hive user interface layer. In this Hive core layer, we have two things. One is Hive query language engine, process engine, and Hive query language. First one is a processing engine, and Hive query language execution engine. These are all the two core components that is present inside the Hive core layer. Then each and every component will need the help of a Hive metadata store, that is Hive metastore. Hive metastore alone will manage all the metadata informations. Each and every component will have an interaction with Hive metastore for each and every activity. Okay, so this is the architectural overview of Hive systems. Okay, so you already know what is a metastore. The metastore you can by default the database that is configured is a Derby database. If you want to make it using your own RDBMS, that is also possible, but that is not at all needed. It maintains the metadata information. By using this metadata information only, Hive came to know what sort of information is present in the underlying layers. Okay, so this is the architecture. Please make user can have interface to any one of the cell. Now we are going to discuss in our initial stages a command line interface called as a Hive shell. Okay, the Hive shell will contain it's more specific to Hive query language. Okay, how to configure? Then in our later stages we can make use of this Hue, which is coming with this Hortonworks distributions. Okay, so here, what is the use of this Hive query language process engine and query language execution engine? Okay, so here these are all the two core components. Hive query language process engine is similar to SQL for querying the data from the schema. Okay, so here instead of writing a MapReduce program directly, what you can do, you can write a program using this Hive query language. This Hive query language process engine will take care of processing. What sort of activity that it will do? It will do two major activity. One is, if a user issuing a query, for example, select employee number, employee name, from a hive empty. The table name means it will check for this hive query process engine will check for syntax and semantics. Whether syntax is correct, whether you have any semantic error means instead of select, if you are typed select, that is semantic error. Syntax means select the employee number instead of that, if you are typed select from employee table employee number command name means it is a syntax error. You all people are aware. It will check for syntax and semantic error, and after that what it will do, it will build a, if everything is perfect, it will check whether the user is having access permission like things, all other activity associated will be done by the, whether the user requested a particular table is present, whether the field associated with the table is present or not, like all the things will be done by the high query language engine. And after that what it will do, it will build a logical execution plan. Okay, logical execution plan will be built by the query language. So this plan will let know Hive what are all the sequence of steps that need to be followed in order to fetch the result as per as the user's request. Then once this plan has been built, we need to execute that plan. That plan execution will be taken care by the execution engine. Okay, the execution engine according to the plan will have a execution on top of the data stored in the lower end, the database layer, and it will do the needed action on top of it, and it will fetch the result, and the result will be given to the user either through the opposite interface through which the user is interacting. So this is the way by which this is the working principle and the data flow of Hive. When a user issue a query and the result of query given by Hive in the following hierarchy. User type a query will be typed using the opposite interface. Here the query is first subjected to Hive query language process engine. The query language process engine will do this sort of activity. At that time it will make use of this Hive meta store, and once everything is perfect and it starts its execution, the execution directly interact with the below end database. The database may be a HDFS or HBase or any other database, and once everything is perfect, what happens here is everything is perfect. What happened here is, so through the same interface, the user will be given the needed result. Okay, this is the way by which your Hive will work in terms with the association with the data stored in your the below database. If you have any doubt in this perspective, please let me know. So far we have discussed about the basic.
Do we have any abbreviation?
Okay, so now we are going to discuss about the working principles of Hive. So the same thing what we did in a more elaborate manner. Why so? Because so while you appear for interview, they will look across these questions. Whether you are having the in-depth conceptual understanding, and you have what is happening in the background, like thing will be expected from you if you opt for a job like architect level opening. Okay, simply typing the query and getting the result of the query is not alone sufficient. You need to know internal, then only if your query is facing with any problem, you can able to resolve that. Please a minute. Now we move on to the working principle of Hive in association with your Hadoop in a more deep. How Hive and Hadoop integrated with each other. Okay, the workflow between Hive and Hadoop. We can define it as a workflow between Hive and Hadoop. Here you have Hive in this side, and you can make it a Hadoop in this side. In Hadoop you have what you are having. You will be having your name node. You will be having your job tracker, and you will be having the data stored in the data nodes. You have multiple data nodes, data node 1 up to you have n data nodes, and each data node contain a task tracker 1, task tracker 2 up to n task trackers. Okay. So this is the storage area. This is your HDFS, what we have discussed. This is the control area. Okay. This is an example of Hadoop cluster. So here under Hive, you have the following. The user can interact with these interfaces. You have I interfaces. It may be a command line interface, it may be a web interface, or it may be interface like you. Okay. Here you will be having the following thing. You have the execution engine, and you have this high processing engine. High process engine. The high process engine internally contains two things. One is Hive driver, and to do all the compilation, we have iCompile. Okay, here we have your Hive Metastore, MS, Hive Metastore. The user is interacting with through these interfaces. When a user gives a query, this is a process engine. The process engine consists of two components. One is Hive driver, and the second one is Hive compiler. Okay, so first, what it will do? The user is issuing a query. Let me take the query and select start from Hive table. A simple query. Select start from Hive employee. Is the table name which was issued by the user. The user will make use of any one of the interfaces to get the query. The query, what happened will directly get into the following thing. Okay. So directly the query will be taken to the driver. First one, the driver, Hive driver. Okay, the driver, what it will do? It will get the help of the following two things: the metastore as well as compiler to execute the query. So what information that it receives from the metastore? It will first get the information. This query is issued by user RAM. Okay, the user RAM is interested in the following thing: the table name Hive table, whether the table is already present or not, whether we have associated metadata information with the table or not. If the table name is Hive EMPL, if a user uses Hive, what it will throw you? It will throw a error table not find. Similarly, if the field name, if a user issues a field name, employee number and employee name, if the original entry is here, it is mapped as employee number, means it also throws error. Like whether the table is present or the field associated with the table is present, like informations will be got from the Hive Metastore. Also, it will also got the information where under which text file that we need to go for. Let me make it this text file is employee.txt. For the Hive employee.txt is mapped with the Hive emp table. Like all the information it will get from Hive Metastore. And after that everything is perfect, what it will do? It will get the help of the compiler. The compiler will do the above said thing. It will do the compilation procedure. Before that, it will check for syntax and semantics. If everything is perfect, it will create a execution plan. These are that we have discussed. Then once everything is perfect, the driver will receive the execution plan and it will send the execution plan to the execution engine. The execution engine, what it will do? The execution engine, it will make a execution plan. It will directly contact to the name node through this HDFS client. Intermediately, we have a HDFS client. The execution engine will contact to the name node. Okay. So user will have an interaction either directly with the HDFS client, or we have a separate client called as a Hive client also. You can have a separate machine for Hive alone, Hive client, or you can, if you configure Hive here from your HDFS client also you can have interaction. So if it is a Hive client, directly the execution engine will have an interaction with the name node, and the name node will have will make a check of all those things, whether the user particular user RAM is having access permission, like all the information, authentication, credential like informations will be checked by the Hive. For that Hive also, for that the name node uses the metadata information that it manages under FS image, and everything is perfect. The particular execution, the execution code will be given to this job tracker. The job tracker will decide the task tracker, and the task tracker will do the execution on top of the data node. Okay, so this is the workflow between a Hive and a Hadoop. This is a Hadoop, and this corresponds to Hive. Okay, this is the way. If you go in depth, the interaction between a Hive and a Hadoop will take place in executing a particular query. Okay, so next we are going to discuss about the installation perspective. The most important thing, how to make an installation of Hive. So for this, we should have the prerequisites. You should have already your Hadoop need to be configured for our practice. Okay, okay. Start with the installation procedure. You can install Hive in two mode. One is a standalone mode or a distributed mode. Okay, so I will discuss the both mode. We need to have some additional parameters for distributed mode. That's all. Nothing there. Okay, what are all the prerequisites? The prerequisites it should be you should have Java JDK. It is recommended to go for minimum 1.7 version and above. This is the first prerequisite. If you are going to install Hive in a standalone mode, then in this case you need a Hadoop in that computer. Hadoop need to be configured. If it is a distributed mode, then no need of Hadoop. So what you need to do is Hadoop will be configured in your cluster. You need to specify the location of this Hadoop name node and Hadoop job tracker in a configuration file. That's all. Okay. In a distributed mode, we have already Hadoop name node, Hadoop cluster has been configured. You need to specify the location in the configuration file. That's all. And you need to configure Hive on top of it. Here too, you need to configure Hive on top of it. So these are all the three things associated. You need Java, you need Hadoop, and you need Hive. We have already a virtual machine which we have configured Ubuntu operating system, and we have a Java JDK 1.7 configured, and we have Hadoop configured. The installation procedure for either Hadoop 1.2.1 or 2.x is same, no difference. Okay, so you can choose Hive accordingly. Now we are going to download and we are going to install Hive, and the sequence of steps that is involved is going to be discussed. Okay, so where you need to go for Hive? So you need to go for Hive from the Apache site itself. Okay, Hive need to be downloaded from the Apache site. So now you need to start the service. If you type JPS, it should list name node, secondary name node, job tracker, etc. etc. Here we are going to install Hive. Already you know this is the location where we have configured Hadoop. Under home, under Hadoop, we have Hadoop hyphen 1.2.1. This is the location where we have our Hadoop configured. Yesterday itself we have discussed about this thing. So under which you have a folder called as a Karnav folder and a bin folder. Okay, this is with the corresponding to 1.x. I will let you know in 2.x. So here this Karnav contains 6 configuration files. Okay, you already know this Karnav folder contains Hadoop-environment.txt. Like you have a core-site.xml core-site.xml, hdfs-site.xml, mapred-site.xml, and have 2 additional files, masters and slaves. Okay, so similarly the bin folder will contain all the script to start the Hadoop cluster, to stop the Hadoop cluster, right? It will contain the start and stop scripts of the bin folder. Okay, here we are going to install Hive under the following location. Under the same path we are going to install Hive. So here, what information that it need to be present here in Hadoop environment.sh, you need this Java's home path, and in core-site.xml, you need to specify the name node's IP address. In a MapRed, you need to specify the job tracker's IP address, and we have another important file .basrc, where the file will be again for each and every user. We have a basrc file under home. Under the username, we have this folder. The basrc file contains three important information. One is you want to specify the Java's home path where Java is installed. Second one, it need to specify the Hadoop home path where Hadoop is installed. Hadoop home path, and it need to specify the class path for both Java as well as Hadoop. That is nothing but the bin folder of Java and Hadoop need to be specified here. I will show all these information. Here only we need to specify the Hive's home path, where we are going to install Hive. That Hive's home path need to be specified. Also, we want to specify Hive's class path also. These are all the two additional things that you need to add into the basrc file. We have already had discussion about how to configure a single node, what information that is present in basrc. For newcomers, I will share you the video. No issue. Okay. Here, now we are going to, if you type present working directory, it will show you that you are under /home/Hadoop. I will show it to you with my settings. Okay. Here, this is my VMware workstation. Here we have this Hadoop configured. Hello. And so phone. For class okay. Okay, this is the order. This is the VMware. On top of it, I had configured this Hadoop. Please wait a while. Class phone இன்னொரு இடத்துல இருக்கு. சரி, திருப்போணம் வந்திருக்கீங்களா? சரி சரி, வாங்க மத்தியானம் வாங்க, வீட்டுக்கு வாங்க, சாப்பிட்ற மாதிரி வாங்க. சரி, மாலா வீட்டில் தான் இருக்கு, மேலே இருக்கு, நான் கீழே இருக்கேன் கிளாஸ்ல. நான் மேலே போயிட்டு பேச சொல்றேன். சரி சரி, ஓகே. The username and password is Hadoop. Username and password is Hadoop. Now we can find that we have entered into the command line mode. Okay, to get it into the CLI mode, this is our terminal. If you type present working directory, now you find that it was under /home Hadoop. This is the home path of the Hadoop user. Being we have logged in as a Hadoop user, this is the home path. Okay, so here you can explore this through this explorer. Click on this explorer. Now you are under home path. I had already configured Hive here. Okay, so I will show the folder Hadoop -1.2.1. I am going to exhibit this. Now we are under this home path. Now under home path, I have configured Hadoop 1.2.1, under which we have conf and bin folder, and all the information of the above set configuration is present here. Okay, under home we have Hadoop 1.2.1. Click and you have a conf folder. Click. Now you can find all the configuration files. So core-site.xml, open with gedit. You can find these are all the properties that you need to specify. Okay, you want to specify the fs.default name. The core-site.xml contains the IP address of your name node. So this is the location. Being it is a single node, I had mentioned it as a local host. Okay. Similarly, we have each and every file will have its own property. So here, being it is a single node, in hdfs-site.xml, I had specified the value to be 1. Why so? Because what's the reason behind that? By default, Hadoop expects your data need to be copied across minimum 3 data nodes. The minimum 3 block replicas need to be there. But Since you are configuring only one single node, then if it looks for the default 3 copy, we need 3 data nodes. Now we are practicing using a single node only. That is the reason we make it as the DFS replication stands for number of block replication. The block replication is made as 1 here. Okay. So because if we have only one node and if it doesn't override this, what happened here is Hadoop will look for 3 nodes and it will result in an error. So that is the reason why we had it here. Okay, these are all the things that we have already discussed. I want to show you what we are having in the .basrc. Okay, so here the .basrc file. This is the file that we are interested. Under home Hadoop, we have a file .basrc. It is a hidden file. It won't reveal. Okay, if you simply go through, it won't reveal. Now we are under the following path. Under the home path, we are under the home path. You can find that here the .basrc is not listed here. So control H will reveal you the .basrc. Control H. You want to type control H. Now you can find .basrc file. Click, right click, open with gedit. So move to the end of the line. Move to the end of the file. Now you can find the following three things. Java's home path. Here Java is installed in the following location. Hadoop is installed in the following location. And the bin folder of the Java and Hadoop need to be specified here. Here on top of it, you need to specify the Hive. Okay, please make a note of all those things. So here you want to be very careful. This Java-7 OpenJDK AMD will be differ in your machine. It may be either if you are using 32-bit, it will be i386. If you are using 64-bit, you can make use of the same thing. Okay, these are all the 3 important parameters that you need to add here. If you are going to use Hive means you want to also export the Hive path. Okay, these are all some of the things that you should have already aware of. Let me save and let me move back. Now to start the, if I type JPS, it shows nothing. Okay, to start the cluster, start -all.sh. It will start the cluster. Now the cluster need to in a running state for running Hive. That is the prerequisites. If I issue the same command JPS, now you can find it will list all the nodes. Name node. Here in this only you are going to install Hive. Okay, you are going to install Hive from this perspective. So if you have any doubt up to this, you please let me know. So Kameshwar Gokul, I will share you. Yesterday we had a discussion on the installation perspective. You will receive the video by today evening. I will share you 4 videos. So please go through that and you will have a clear idea. I will also take this session for you. No need to worry about it. Installation of Hadoop 1.2, everything will be having a separate session on the coming week on any one of the weekdays. Either probably it may be on a Thursday or Friday. For you separately, it will be around 1.5 hours to 2 hours. I will let you know before coming up for the next weekend session. You will know the installation of 1.x, 2.x, and multi-node. Now, to make you accommodate in a comfortable manner, I am showing all these things for you. Is it okay? How a file will look like, what information that you need to go for. Now we are going to start the installation procedure associated with Hive.
Yes, sir.
Now we are in the following location. We are now in the following path, home/Hadoop. Okay. So your present working directory shows that you are under home/Hadoop, under which we are going to install. So here the command for installing Hive is wget. You want to download this Hive URL for installation. Wget Hive URL. Where you can get this Hive URL? So go to Google, click download Hive. Now you can find this download Apache Hive from Apache site hive.apache.org. This is the site where you can download. Okay, click on this site. download a release now. These are all the releases. Okay, the last release which was released on April is Hive 1.2.2 is the last release. You can go on and check with the available releases. Okay, so December 20 release 2.1.1. These are all stable releases. They may have a slight variant. Okay, so you want to go through the document which support your release. Now we are going for a release which support Hive 1. Hadoop 1.2.1. Click on here. You can get this anyone. So I am looking for Hive 1.2.2, or you can go for the above set. Okay, it is your choice. So this is the file that we are in need of, Apache Hive-bin.tar.gz. What's the difference between this source.tar.gz and bin.tar.gz? Okay, if you want, it will get the source code of the above set Hive, then you need to download this. The source code will be given to you. On top of it, being it is open source, you can do any modification as you like. For that, you need to download this. Whereas, we need a binary, so we need to download the following thing. Simply right click and you copy the link address and move here. You can find this is the command. Okay, wget. Simply right click and paste. You will get the particular file here. wget http, you can get the particular file here. Okay, so this is the way by which you need to download. Okay, so please make a note. You can get a more appropriate version. These are all the associated Hadoop files will be present here. Okay. So if more specifically, if you are interested in download Hive 1.2.1, you can directly specify this also. You can get from any repositories. Okay, you can get from any archive. Apache Hadoop releases. You can get this from any repository. So it may be a Maven repository or maybe from any archives. So here we have the archives stored here. Hive 1.2.1. Again, this is the Apache Hive 1.2.1 bin.tar.gz. This is the file that you are interested. Okay, this is the file that you are interested. Whose size is 89 MB. Please make a note. So if you are looking for a older version, you need to go for this archive.apache.org. So here we have only the current version, means directly hive.apache.org. So here it contains the current version. Okay, it contains the archive version. Right click, copy link address. You simply wget and paste the link address. Paste, enter. Now Hive is downloading. Okay, let me wait until it downloads. Where it will be downloading this Hive URL, it will download a Hive under the following location. Under home, under Hadoop, we have this Hive-1.2.1. It will be in a tar.gz format. Tar stands for a tape archive, gz stands for a zip file. So here what you need to do, once it is downloaded, you want to untar it. What is the command to untar? Again the command is tar-xvf. X stands for extract, extracting the zip file. F stands for the target file. You want to specify the file. Okay, this file hive-1.2.1.tar.gz. This file need to be specified. So after that we will get a folder. After untar we will get a folder hive underscore home underscore. Here you have the tar file comes as Apache -hive. Okay, Apache -hive. You have a folder by name Apache -hive hyphen 1.2.1. So this is the activity that we are going to do. So get the URL, and if you want to get the current URL, you can directly download from this Apache site. Else, if you are looking for old URL, old version, you need to go for this archival site. Then you doubly get the Hive URL, will download the URL under the following location, and you have a Apache-Hive tar.gz file, and then you want to untar it, tar-xvf, you want to specify the file to untar it. Now you will get a folder. So in this folder, there exists a conf folder, and we have several things we are going to discuss now. Now let me check whether it is downloaded. Okay, it is downloading slowly. 33% has been downloaded. Now once it download complete, we do this activity. It all depends upon your internet speed. And let me discuss until it downloads. Okay. So after that, what we need to do? So you open the .bash rc file. Open the .bash rc file. In a .bash rc file, we have already contained export. Where this file will be? It will be under the following location. Under home, under Hadoop, you can find this file .bash rc file. Okay. Export. You have already Java underscore home. You have export Hadoop underscore home. The home path for Hadoop you have specified here, and you have already under export the class path equal to $path colon etc. This thing that I had shown to you. Okay. So you can find you have the following thing. Okay, under home location, under this Hadoop, under home path, you have this bash.rc file, .bash rc file. Where it is? Bash rc. Right click, open with gedit. It's an editor. You find all the three things. So here what you need to do, you want to once again export the Hive path. Okay, you want to type export capital letter Hive underscore home. Please make a note of all those things. Hive underscore home is equal to /home /Hadoop /Apache Hive 1.2.1. This is the location where we have installed Hive. Similarly, under this path, $Hive underscore home /bin. Okay, sorry, it need to be in a capital letter. Sorry, Hive underscore home /bin. So this is the class path. And apart from that, what you need to do is, you please make a note of what you need to do. Hive home path and Hive class path. Apart from that, you need to specify the lib location, lib folder of your Hive. Okay. Export class path equals $class path :home /Hadoop /Hadoop-1.2.1 /lib folder, library files, that we need all the library files, all the files under the particular working directory : dot. Similarly, what you need to do, export class path for the same thing equals $class path colon, you want to specify the location of your hive. Home slash Hadoop slash Apache hyphen hive hyphen 1.2.1 slash lib slash all the lib library files. We are including the path of library files under the current working directory. Okay, all the files will be linked to the current working directory. That is the dot command at the end. So this thing need to be enclosed. Please make a note. You want to specify the home path and you want to add the path into this existing line and you want to type these two lines as a separate. Okay, these are all the prerequisites. After that, what you need to do, you want to type the source dot bash rc. Why you need to type this command? So this configuration need to be notified. It can be notified in two ways. Either you need to restart the server. You need to start the server. Else what you can do, without restarting the server, if you want to do, you want to give source.bash rc. These are all the two ways that you can do this. Source.bash rc. Please note down. Source space dot bash rc. Then what you need to do next, after finishing all those things, you need to do some configurations. In Hive, you have a file by name hive-environment.sh. You have a file by name hive-environment.sh. Okay, where the file will be? The file will be under the following path. Under home, under this path, you will be having a folder called as conf. Under the folder, you find the file hive-environment. You please carefully note down all those things. So under home Hadoop Apache Hive, you have a folder by name conf. Under conf, you can find a file hive-environment.sh. Initially, you won't have the file. You will be finding a template file. From this template, you want to create the file. How to create the file? You move to the location. To move to the following location, cd change directory into the location /home /hadoop /apache hive -1.2.1, under which you have a conf folder, and you move to the location. There if you type ls, you can find this file hive-environment.sh.template. What you need to do, simply copy hive-environment.sh.template. You want to copy as the hive-environment.sh file. Okay. Now you have hive-environment.sh file. Under that file, what you need to do, you open this file. Okay. So either by using a VI or by using gedit, you open this file. Gedit hive-environment.sh file. You want to specify the Hadoop home path here. Export Hadoop underscore home is equal to HODO. You want to specify the location home Hadoop 1.2.1. Okay, this is the location where you found. So these are all the thing by which you need to install. Please make a note. So apart from that, what you need to do, you want to also create some additional things. Let me check whether we have a card. Please make a note of first all those things. Okay, you want to specify after downloading and open the bash RC file. It will be under /hope. You have already these three things that I have shown to you, and you want to specify the opposite path. Then what you need to do, so you need to go to this configuration of Apache Hive. You will be also having a configuration for Hadoop. You should not go for that Hadoop config. You have under Hadoop 1.2.1 also, you have a Conf folder, not that Conf folder. You need to move on to the Hive installed folder under which you have a Conf. You can find a template file and you create a hive.environment.sh from the template file by simply issuing a copy command. CP is the copy command and you type the line for this. This setting, or are all the thing that we are mentioning, this setting, if you configure Hive in a distributed mode. For a single node, you no need to go for single node. What you need to do, you want to let Hive to know where Hadoop is configured. So this is for distributed mode setting. Even if you go for single mode, it won't result in any error. Okay, it is best practice to include here. No issue. Let me check. Okay, I am going to remove all those things. Let me check whether Hive downloaded or not. The password is Hadoop. Yes, now you have Hive. You can type ls. Now you can find you have Apache Hive 1.2.1 bin.r.gz. You can find this file. Okay. So what you need to do now? Now is it clear for you? Can you able to view all those things? You are now present working directory in home/Hadoop. You can find a file Apache-Hive 1.2.1 bin.r.gz. So now we are going to untar it. tar-xvf Apache-Hive bin.r.gz. Now it is untarring. Yes, clear. Now if you type ls, now you can find a folder. Okay, you can find a folder Apache-Hive 1.2.1 -bin. Okay, so if you move on to this folder, let me open this here. This is your home path. You have Apache-Hive 1.2.1. Click here. There is a corner folder. Click here. You can find the template here. Hive-environment.sh template. You want to copy and you want to again paste. So here you rename it hive-environment.sh. That's all. Okay. Hive-environment. This is the file. Open this file with the gedit. At the end, what you need to do? Go to the end. At the end, you want to specify the export. What you need to do? Hadoop underscore home is equal to, you want to specify the home path /home /Hadoop hyphen, sorry, this is user Hadoop /Hadoop hyphen 1.2.1. So this is the location that you want to specify. Simply save the file. Save. Okay, the first part is over. Next, what you need to do, go to home directory, click on this home directory. It will show you this bash rc file. Okay, bash rc. You can find .bash rc here. .basrc, click on open with the gedit. At the end, you want to type all those things. What are all the things that we have mentioned here? Export hive underscore home is equal to apache hyphen hive. Here what will be here? So apache home path, you can apache hyphen hive 1.2.1 hyphen bin. That is very important. Please make a note. 1.2.1. Okay, hyphen bin. Where is bash or C? Open with gedit. Go to the notepad. Export hive underscore home. Simply copy this. Come here. You paste. Okay, export hive underscore home Hadoop apache hyphen hive 1.2 hyphen b. Next, what you need to do here, you want to specify colon dollar capital letter hive underscore home slash bin. And after that, what you need to do, you want to specify the class path, these two class paths. Okay, so apache hyphen hive hyphen 1.2.1 hyphen bin. Okay, so this class path, simply copy and paste here. That's all. Okay, you want to be very careful. We want to check it again. Hadoop home bin, hive home bin, export class path equal to class path home Hadoop lib apache hive hyphen bin slash lib. Okay, save this file. And after that, we have Java home, we have Hadoop home, we have hive home. Also, we have class path for the lib folders. So just after that, what you need to do, you want to simply source dot bash rc. Everything is perfect. Okay, everything is perfect up to this. Next, what we need to do for running hive, we need to create some temporary directories. Okay, you just follow this thing. You want temporary directories for running hive under the HDFS location, not on your Linux file system, under your HDFS location. Okay, so you know HDFS is a separate entity. So here this is your Linux file system, what you are viewing now, and below we have a HDFS file system. It is mapped. Okay, so if you simply type ls, it will let you know the Linux file system. For example, here in this command prompt, if I simply type ls, I am interacting with this Linux file system. You please make a note. If I type ls-l, it will list what is present in the Linux file system. Okay, so here if I want to interact with this Hadoop file system, I need to run a separate command. This is your Linux file system. So if I want to run the same ls, here what I need to do is bin slash Hadoop fs hyphen ls. This is the command that I need to go. So bin slash Hadoop fs. Before that, what I need to do, I should move to the following location: cd slash home slash Hadoop slash Hadoop hyphen 1.2.1. This is the location where I need to move, and from there I need to execute this command in the dollar prompt. So now what happened? It will list all the files into the present working directory of your HDFS file system. Please make a note. Now what I need to do, I want to create a temporary, under temporary I want to create a hive folder. and also I need to create under user under Hive a warehouse. These are all the two things I need to create now. Where I need to create under HDFS. Okay, for that the command is again I want to move to the location into the folder where I have configured Hadoop. So if you type bin/Hadoop FS, it will list the root directory of your HDFS. Now the root directory of HDFS contains the following folder user/hive. I will share it to you. Now if you type present working directory, you are under home Hadoop. To move to the location Hadoop 1.2.1. Now if you type present working directory, you can find here. Now the command is bin/Hadoop fs space -ls. You want to specify the root. Now you can find you have a folder by name home. Okay, you have a folder by name home. bin/Hadoop fs -ls. Okay, what you need to do, you want to create, if you simply type ls, differ, you have the following information listed. Okay, if you type bin/Hadoop fs/ls, you find you have only one thing listed. Okay, this is the way by which your Hadoop file system, HDFS file system differs from a local file system. It is a mapped. Now what you need to do, you want to create a following temporary folder bin/Hadoop fs. The command is -mkdir. You want to create a temp/temp. A temporary folder is created. Then what you need to do, you want to under the temp, you want to create another folder called as hive. Okay, the same thing. You want to create under a temp, you want to create another folder called as hive. Similarly, you want to create another folder. You want to create a user. So under user, you want to create, it is used for storing hive. Okay, after that you need to create a warehouse. I will share in the document, it will be easy. So what I am doing is I am creating the user hive/warehouse folder, and I want to assign this property. Okay, I want to set the property execute property for all. To set the property, the command is -chmod the 777 -R. Okay, this is the command. Now I had set the properties. What I did, now if I find that bin/, I had created two folders. One is I had created a folder by name temp/hive, and I have created a folder user hive warehouse. These are all the two things that I need to do. Okay, where under HDFS. After that, what I need to do, I want to set this read, write, execute permission to all this folder. For that, the command is chmod. Chmod permission 777. I want to specify this -r/temp/hive. So it will have all the permission. Similarly, the command is chmod 777. These are all Linux command -r/user hive warehouse. I want to set the permission, read, write, execute permission for this opposite folder. Okay, so I am going to execute. Being it this folder is in HDFS, what I need to do, I want to prefix bin/Hadoop fs -chmod. That's the thing that I need to prefix. If it is a Linux, directly I can execute this command. Being it is in HDFS, that command need to be prefixed with bin/Hadoop fs. Okay, that's what that I am going to do. Please make a note. I have created this two bin/Hadoop. That means Hadoop, the command is going to run on Hadoop file system. Hyphen chmod. I am going to set permission 777 first for the temp file. Yes, permission has been set. I am going to do the same thing for Hive folder also. So Hive. Yes, permission is set. Now I am going to do it for, now I have another folder by name user. Chmod user. Yes. Now under user I have another folder Hive. I am going to set permission. Yes. Under Hive I am having another folder called as warehouse. Okay. Now I had created the folder and I had set permissions for all the folder. If I make a check, if I want to make a check, what is the command? Simply hyphen Hadoop fs hyphen ls root. It will list all the three folders. Now we can find the home, the user folder and the temp folder. Okay, everything is perfect. So now what you need to do? Now you want to start the Hive. So once everything has been over, we have installed a Hive. Here is the location under the home. We have installed a Hive. That is you have Hadoop 1.2.1. Also we have Apache Hive has been installed. Apache Hive 1.2.1 bin, and we have specified the path under that bash rc file. Okay, under bash rc file we have specified the path, and we have created two directory under HDFS temp Hive and user Hive warehouse. And what we did, and we have set the permissions of directory to read, write, execute. And now we can start the Hive. Okay, so if you type JPS, you need to list all the services are running. Now I am going to start the Hive. Okay, the command to start the Hive is bin/Hive. So you want to why it is throwing error. So I am now in the Hadoop home path. Move to the Hive home path. Okay, present working directory. Now I am in the home Hadoop. Move to the Apache Hive. This path. Now in this path you type this command. So bin/Hive is the command. Now it will start the Hive. Logging. If you have done any error in the configuration, it will listed here. Yes, now you got the Hive. Okay. So here you can find the tables. Show database. Now you have one database called default database. So this is the Hive shell that we got. Okay. If you find a show tables, it will list you all the tables. Currently there are no table. You need to get into the database. All other things associated with Hive will be discussed. Now we have discussed about the installation part of Apache Hive. Okay. Recall what I did here. First what I did. Now the prerequisite is I need Java JDK and I need Hadoop 1.2.1, and here I am going to install Hive-1.2.1. So I had already under the home path of home/Hadoop. Under Hadoop I already have Hadoop-1.2.1. This Hadoop corresponds to username. Okay, this is your software, Hadoop software. Now what is the command to install? wget. You want to get the Hive URL. Then the Hive will comes in the following manner. Okay, Apache hyphen Hive hyphen 1.2.1 hyphen bin dot tar.gz. This is the file that will be downloaded. What you need to do? Tar, untar it. Tar hyphen x you want to specify. Now you will get a particular folder. Okay, you will get this following folder. So under that folder, what you have? You have a corner folder. Under the corner folder, you have a template, hive hyphen environment.sketch template. Under the template, you want to specify the Hadoop's install location, Hadoop home part. That is the first step. Okay, good. Then after that, where we need to put this entry. So under home, under Hadoop, you have .bash rc. This bash rc file already contains the following information. You have a Java and Hadoop home. You need to add a hive underscore home, the installed path of hive, Apache hyphen hive hyphen bin. Similarly, you have already this path. Under the path, what you need to do, you add a colon and install hive underscore home slash bin. And apart from that, you need to include the library folder of Hadoop as well as the library folder of Hive. These are all the things. After that, you want to issue the bash RC. Okay, so bash RC. Now what you need to do? You want to create everything is perfect. Now you want to create two things. Yeah, folder by name temporary Hive, and another you have user Hive warehouse. These are all the two folders that you need to create. Under which location that you need to create, you want to create under this HDFS. Okay, so for creating this under HDFS, what you need to do, you want to move to the location first, cd home, cd Hadoop, and then you want to move to the installed part, Hadoop hyphen 1.2.1. From here only you can execute the command. The command is bin slash Hadoop FS. Okay. So first what you need to do, you want to create hyphen make directory. You want to create a directory under tab. Similarly, you create a directory hive under, you create all the directory. And after that, again you want to set by ch mode. You are setting 777. Similarly, by the way you create directory, you want to set the permission. Okay, everything is perfect. Now you move to the location of hive, cd home slash Hadoop slash Apache hyphen hive hyphen 1.2.1. Move to the location that is hyphen bin. Okay. From here you simply type bin slash hive. It will take you to the hive shell. Okay. This is the hive shell. This is the CLI mode shell that we got. Okay. So this is the way by which you need to install hive. Once installed hive, we will have discussion on how to look into the hive, how to create a directory, everything will be discussed. Simply the command that we have discussed is how to, before going into that, what you need to know, you need to know the data types associated with how to create a table, etc., everything that you need to know. Do you have any doubt with respect to this? Please let me know. Simply you need to create a database. Under the database you need to create tables and so on and so on. Everything in Hive need to be stored under database. Okay, that thing will be discussed separately. Okay, if you have any doubt with respect to what we have discussed so far.